There are some integrals involving square root of quadratic equations may not possible to be solved by the simple substitution techniques as we discussed in the previous video. So in this case, we may use a trigonometry substitutions to get rid of such problem. That is, if the integral have the following form. Okay, if we have such form, then we may apply these trigonometry substitutions according to the case to solve the problems. Let's look at the first example. The denominator for this problem actually is equal to square root of 1 plus 9x squared to the power of 3. So we couldn't solve this directly and we have to use the previous tables that we have looked at. In this case, we have something like a plus bx squared or a squared plus b squared x squared. So yeah, we have to choose this. It is in this form. So we have to choose x equal to a over b tangent theta. So if we compare this, our a should equal to 1 and b has to be 3. So x is equal to 1 over 3 tangent theta. If we find the x, the theta, that will give us 1 over 3. Differential tangent theta actually give us secant square theta. So dx gonna equal to 1 over 3 secant square theta d theta. And now we can substitute all the informations into this problem. So we have 1 over 1 plus 9 and then 1 over 3 tangent theta square to the power of 3 over 2 for the whole term, and dx become 1 over 3 secant square theta d theta. This term is actually equal to 1 over 9 tangent square theta, right? So this 9 and this 9 can be cancelled. So what we finally have is, I bring the 1 over 3 outside first. So 1 over 3 and then 1 over 1 plus tangent square theta to the power of 3 over 2 times secant square theta d theta. And we need to apply some trigonometry identity here, which we know that 1 plus tangent square theta is actually equal to secant square theta. This is trigonometry identity. And hence this part become 1 over secant theta. I can write it in this form, either secant square theta or secant theta to the power of 2. Okay, here I write it to the power of 2 and then times with the power of 3 over 2. So these 2 and these 2 can be cancelled, and times with secant square theta d theta. Okay, here we have secant theta to the power of 3 and times with secant square theta. So for this one, we can simplify it to 1 over 3 and then 1 over secant theta d theta. We have not enough space here. Let's continue at the next page. So To integrate 1 over secant theta, we have to take note that actually secant theta is equal to 1 over cos theta, or we can say cos theta is equal to 1 over secant theta. So this one finally becomes cos theta d theta. To integrate cos theta, that is very easy. We will get sin theta. So this is the answer for this problem. In the next example, the square root of quadratic equation is here. So we need to rewrite it as x squared plus 4x plus 3. We have to rewrite it as x plus 2 squared minus 4 plus 3, which gives us x plus 2 squared minus 4 plus 3, that is minus 1. Okay, the way how I rewrite it is actually for quadratic equations. Let's say I have ax squared plus bx plus c. If I want to rewrite it in the forms of something like this, so I can take the a out first, and then I have a squared plus b over ax plus c over a. So if I want it to be in the form x plus something squared, so I write x plus and then half of this. So means that b over 2a squared and minus b over 2a squared and plus c over a. The reason is because this x plus b over 2a squared going to give us x squared plus 2 times b over 2a x plus b over 2a squared. That is because, let's say, x plus c squared actually gives us x squared plus 2cx plus c squared. Okay, so now back to this. So these 2 and these 2 can be cancelled, and hence the square of this is x squared plus b over a x. So we get back this. But we have an extra terms b over 2a squared. So that's why we need to subtract it back. This is your previous lesson in quadratic equations. This is just a very quick revision on that. Now let's back to this. So this one then I can rewrite it as x plus 2 over square root of x plus 2 square minus 1 dx. Up to now, we're still not able to solve it. So since we have the square root of quadratic equations, what we can do is we can back to the table and choose which one we may use for the substitutions. What we have is the square root of x plus 2 square minus 1 just now. So actually we should use this, where our a is equal to 1, b is equal to 2, okay, and c is equal to 1. So what we can do is we can substitute ax plus b, means that our x plus 2 later with c secant theta c is 1. We can substitute our x plus 2 later with secant theta. So if x plus 2 equal to secant theta and x is equal to secant theta minus 2, then I find dx d theta, which will give us secant theta, differentiate secant theta is secant theta tangent theta. Okay, so I swap this, I bring this one to the other side, and that gives me dx equal to secant theta tangent theta times d theta. Okay, now let's back to this. Since the substitution x plus 2 is secant theta, so I have secant theta over square root of secant theta square minus 1, and dx is secant theta tangent theta d theta. We just take note that in the trigonometry identity, secant square theta equal to 1 plus tangent square theta. So, secant square theta minus 1 actually equal to tangent square theta. So, this one, we can rewrite it as secant theta over square root of tangent square theta times secant theta tangent theta d theta. So this square root of tangent square theta is actually tangent theta. So this term and this term can be cancelled. So what we have is actually secant square theta d theta. This term times this term give us secant square theta. Okay, we have not enough space. Let's continue in the next page. To integrate secant square theta, the answer should be tangent theta plus c. And now the question, what is this tangent theta? Remember, previously we do the substitution. X plus 2 equal to secant theta. And secant theta is equal to 1 over cos theta. So in this word means cos theta is actually equal to 1 over x plus 2. I just swap this one and this one. So if I sketch a triangle, which is 90 degrees here, so cos theta is equal to 1 over x plus 2. Then I use the Pythagoras theorem. This line should equal to x plus 2 square minus 1 square, which is equal to x square plus 4x plus 4 minus 1, so it's plus 3. So tangent theta, if according to this triangle, should equal to this line over this line. So it's square root of x squared plus 4x plus 3 over 1, or equal to sub of x squared plus 4x plus 3 plus c. So this is the final answer for this problem.